All right. Well, the title sort of says it, so I just want to start this out by. This is more of a vendor talk. I tried to make this vendor agnostic, but it just doesn't really work because the software that I'm talking about here is integrated into the ClusterStor product. So that's what this is ultimately going to be about. So I hope that's okay. So what I'm going to go through here is the feature itself, the auto-tiering feature, why we're doing it, what it is, some of the architecture, and the components and how they interact. Maybe more interesting is some of the practical examples for using this feature. And then if there's time to talk a little bit about the roadmap. Not a lot there, but just wanted to touch on it if there's time. So why are we doing this? For the obvious reasons. Cluster file systems can get very, very, very large. We don't have any good insight really into all the files that are on the file system, how big they are, how old they are, directories that are consuming more space than others. We need a way to efficiently look through the file system and see what's there. There's not a lot of automation unless users build their own tools or scripts. So this is what the auto-tiering feature is trying to solve. And the other big one here with tiering in the name, hybrid storage systems are pretty common now. So flash, small, expensive, disk, cheap, big. We need a way to move files back off of that flash storage. We want to be able to use the flash as much as possible. So we need to be able to move files off of there when they're no longer actively in use. And we'd like to have that automated. The other thing that I would mention here is that auto-tiering is probably a little bit misleading as far as the name, because a big piece of this is the indexer and search capabilities, which is necessary, obviously, for all of this to work. So we're going to talk a little bit about that too. All right. This is a little bit of a map of what how everything is laid out. In the middle there is the management unit. ClusterStor has a pair of management nodes that provide all the management functions to the file system and storage. This is where the tiering software lives. It's installed on the management node, and the management node acts as a Lustre client to move data around. We can scale it out. You see down at the bottom there, those 1U nodes, we can scale this out. It's basically linear scaling. Can add what we call data movers or utility nodes. Okay, so mentioned this already. We need a way to efficiently find the files so that we can move them. LFS find is too slow. Imagine a file system with 1 billion files and trying to search the entire file system. Just not doable. So what we do here is we index the file system, break up those indexes into smaller database files and distribute them within the Lustre file system. So we don't have any external hardware and we don't have to maintain any external hardware. So we're using the Lustre file system so we can scale, essentially unlimited scale, depending on how big the file system is. We update those database entries a couple of different ways. we can use change logs, which is a better way because we get a better focus on what has changed. But we can also do full or incremental updates based on policies. We have an RPM that you can install on a client so that the client can access those databases as well. This is all based on user privileges and that can be controlled by the admin. But a client can see into those database entries and find any file on the file system. We can report out a couple of useful formats. And all of this is all parallelized for efficiency. This is just an example of using the query tool. A few examples here. The first example is probably the most or straightforward. Query command with JSON output. The -C tells us which columns we want to grab from the database. -W is like a where clause. In this case, we want to look at all the files in the flash pool. The where clause, we can put a bunch of those together. They're ANDed together. And there's a few more examples in here. You can see that they get progressively more complex. But we can do a lot of things with this command. And again, this is all parallel. So I have some examples in here of searching a file system with 500 million files in under a minute. So okay, so this is the policy engine. Query finds the files. The policies describe what actions to take when the files have been found. Users can create policies, but most often, obviously, admins are going to be doing this. We use a Robinhood syntax in our policy files. These are regular text files. They're also stored on the file system in a special directory. The trigger agent is monitoring the file system for any changes in file sizes or time. We can do a lot of different, we can set up a lot of different conditions for this. Okay, so the query, well, I'm going to move on here. The indexing agent essentially operates off of the same triggers. So we can set up a policy to trigger at a certain time to go out and incrementally update the index files. And I mentioned before, I think that one of the mechanisms is to use modification times on directories. So we set up a policy that says, every 3 hours, go out, look at your database indexes, stat the directories that are in those indexes. If they've changed, go out, trash that directory, in the database and rebuild it. It's just a more efficient way of doing it. So here's some of the things we can do with the policies. Migrate, pretty obvious. This is the one that's going to allow for our tiering. We can move from one OST pool, for example, to another. Change layouts after the fact. So as another example, if the file system's not set up correctly and we have a bunch of files that are spread across all the flash OSTs and some of the disk OSTs, but we want to move them into a flash pool or into the disk pool, whatever, we can go out and find all of those and assign a pool to them so that they're in the proper locations. Delete, it's pretty obvious as well. This is important to some people or some users to be able to go out and find all the files that are of a certain age and purge them. And then, like I said, we can do reports. So we don't necessarily want to act on the files that we find with our policies, but we do want to report. And then we have an exec function, which is somewhat of a, well, hidden function, I would say, because you can do a lot of damage with this, but it is there. And it's very useful as well, right? Because we can take basically any action we want on the files that we find. And then we have the two index, incremental and full. Full indexes are pretty expensive, so we don't really do those, but incrementals are common. All right, some use cases for this. Flash tier hygiene, already talked about that. That's pretty obvious. Files reach a certain point where they're no longer being actively used. We want to get them off of the file system or off the flash pool and into disk. Scrubbing files off the file system after they've reached a certain age. Usage reports, rebalancing OSTs. I kind of mentioned that a little bit. Drain a failing OST. This is kind of nice. We can set up a policy to do this. If OST that's clearly going down and we want to get all the files off of it, or all the files that have a stripe on there anyway, we can write a policy to do this instead of manually going in and finding all those files. Restriping large files. The things mentioned here from a database point of view, we can write raw SQL to those databases as well. So we can extract a lot of information and do some pretty clever things with the database. I think there's an example at the end of this, a histogram of the file system. I think it's the 500 million files in under a minute. So it's pretty efficient. As far as setting this up, because we're integrated into the software, we use the cluster store CLI. It's as simple as tiering enable. This will start everything up. All the services run in containers. And if we need, or if we're planning to use change logs, there's a little bit of prep that we have to do here. The policies, like I said, are stored in this special directory, .plc files. Probably important to note that the administrators control access to all of this, because users can get themselves into trouble. So, fair. And then I mentioned the RPM that we have also in that directory, which we can install on a client, and the client can get access to the databases as well. Okay, some use cases. So here's a policy. Like I said, we use a Robinhood syntax here. We're defining file class, large flash. We're looking for files that are over 100 meg and live in the flash pool. The rules after the query has been initial. Well, so the rules define what the query is looking for. Looking for files in the large flash file class. The action is to migrate those files to the disk pool. And this is if those files are over 2 days old, or their modification time is over 2 days. The trigger here, we're going to run this every 10 minutes. We're going to run it on the flash pool, and only if flash is over 75% full. So when this happens, we get beyond that 75%. We go in, we look for these particular files, we batch them up, and we migrate them. Because we do this in batches, we might overshoot the 75% a little bit, but we'll stop once we get below the 75% threshold. Okay. Another use case, purging old files and reports. This one is together because this is essentially generating a report while we're deleting reports. So in this particular case, we're saying that we have files that we're creating called purge records, whatever, purge reports. The action here is to go in and delete those if they're over 7 days old. But we have a report path in here as well, because when we trigger on this, we're going to generate a new report. The partition count is 1 because we know that there's only going to be a small number of these files and we only need to run it one time. The trigger is cron style. What is this? 5 after 3 every day? No. So there's a few ways that we do it. We use cron for time-based or condition-based. Last is this exec example where we're going to go out and look in a particular subtree and do calculate the SHA-256 on all the files in that directory and store that output in a reports directory. And the trigger on this one is schedule once. So by touching this file, it will go out and run it, but that's the only time it runs. So it's not a recurring type thing. You have to actually touch the file to make it go. All right. So database placement, this one's a little more, hopefully this helps. So the index shards are at level 0 and 2 directory level by default. This can be changed. There's a file within the DB index directory that allows you to change where that file lives. There's really no need to change it, but it is possible to change that. There's really one at the root level, and then there's one at the second level, like I said, across the file system. If those DB indexes get to be too large, they will split. By large, I mean more than 5 billion files. And this is based on some efficiency work that was done. That's actually the right number. You get beyond 5 billion and things start to slow down. But up to 5 billion, performance is not impacted. Shard placement, I already mentioned that. The DB index files are owned by the parent. So that's what the color coding is trying to show here. Everything inside that top box is what's in that DB index for that root level directory. Everything under Jane, everything under Joan, they only see the files that are in their directory tree. And depending on the permissions that they set on that file, they can either make that read only, they can prevent access from it, but they can also delete it. So can't stop that. But if that file gets deleted, it just gets recreated the next time we come around. So that's not an issue. Like I mentioned, this is all managed by the admin. You can set up deposits permissions on the database files. By default, we're wide open. Everybody can see everything. And typically that's okay because of the parent structure of the DBs and who actually sees them. But there can be some situations where there may be an index file that's sitting at the parent directory And below that, there may be some files that aren't supposed to be seen, or their security privileges are much tighter, and that can actually leak up into the database index above it. So you may want to control that. We can make it as restrictive as we want, or as open. Mention the performance piece of this. Everything scales out across the SMU and the utility nodes. The shards are parallelized. We have index writers that are spread across all of those nodes, and they're parallelized on the nodes themselves. So the performance is significant. I mean, there's some numbers there, but I know in my own tests, under a second is pretty common for searching the entire file system. And that's up to, like I said, well, you get up at 500 million, it's a little longer than that, but so. And then within ClusterStor, we actually have some Grafana where we can monitor the metrics and see what the indexing is doing. And then I mentioned the roadmap. This is really an evolution of what HPE was working on before, which was CDS, ClusterStor Data Services. Some people here may be familiar with that. That was a standalone product. That was its own hardware. And it had its own set of limitations, its own network. Like I said, its own hardware. It was challenging. So CDS has gone away. Now the software, the tiering software, is fully integrated into the ClusterStor software stack, and it's a base feature. Where CDS was something you had to purchase, this is included with the software. So what we're looking now to do is maybe integrate some copy tools and improve performance if possible. That's it. That's what I've got.
Mike Solari with the National Renewable Energy Lab. A few questions, and since we are running CDS right now, that it's going away, but areas of like D&E and auto-tiering, data and metadata, can be used with this, cannot be used with this?
Yes. Yeah. And I mentioned that yes, we support all of that. Yeah.
Okay, I was just wondering because data and metadata, I don't think works with pools. I may be wrong. I don't know in a PFL, but I'll figure that out. Now, you talked about data movers. Mm-hmm. Can those be in supplement to the SMU nodes? And how do those tie in?
Yeah, that is what they are. They're optional. If you get the performance that you need out of just the SMU, that's fine. But if you are scaling out, we add data mover nodes for linear scaling, basically. So you're running more indexers, you're running more, data movers. So.
Yeah, that's kind of what I had. And I'll be picking your brain later, I'm sure.
Yeah.
Megan Larco of Translucent. A question on your migration. When the data is migrated, say off faster storage onto, slower spinning disk or something, is the tool capable of getting all of the information about the file? I'm thinking of things like extended attributes and stuff like that, so that they are migrated as well.
Yes.
Yeah, hi. D from Oracle. You mentioned about that there are multiple log reader to be assigned to the MDT randomly. Mm-hmm. I don't know. But the MDT changelog is actually can only be accessed sequentially. So how do you assign like multiple?
Well, but each MDT has its own change log.
Oh, you're talking about DNA.
Yeah.
Okay. Thank you.
John Fergala, NVIDIA. You mentioned in your future enhancements integrating copy tools. Can you describe what that means? Is it copy ingesting to the file system, exporting data out of the file system, or is copy within it?
Exporting data out of the file system. Yeah, that's what we're looking at.
Makia. So you mentioned that the indexes are in the file system. And what testing has been done on full OSTs where the index is in the full OST, and any other problems with the file system where you're trying to, like, because now all your query tools are accessing a file system that might be unhealthy at the time, is just, cluster store so cool.
Yeah, it's that.
Okay.
Yeah. I don't know about that testing. I have to get an answer for that. I'm not sure.
Jesse Agridge. So the files that are stored on the file system, could they be replicated, or I guess ensured that they're on distinct failure groups? So, your shards are not on the same OSTs. So if you have an OST failure or something, like you may have an extra copy or file number.
Yeah, you can set that up. Yes.
Okay.
Hi, Dominic Mano-Lannel over here in the front corner. Yeah, there you go.
Yep.
So I'm happy you guys came around to using the POSIX permissions with our Goofy index. We found that to be the biggest win. I'm curious on your incremental update process. Is that something you have running, or is it sort of a future idea? Because
no, it is running. So that's all policy driven, incremental updates.
So a user defines what they want.
Yes.
Okay.
Yep.
Got it.
Tom Crow, Indiana University.
Yeah.
If you're turning this on a file system that already has a lot of data, the changelog reader will catch, the deltas. How do you initially index everything? How's that initial load happen?
Well, we do. So we go out and we do a full index. I'm not really sure what the overall impact is on that full index. I'd have to get you an answer on that. But that's, we have to populate those index files. So we have to go out and look at everything. But the more you have running, the less impact there's going to be.
Hi, Andreas Stilger, WAMCloud. The database files, are they hidden in some way, or could users, if they appear in their user directory, are they going to, what is that? And I'm going to delete it?
Yes, they're not hidden. Okay. They can see them. Yeah. So that's why I mentioned that a user can delete that file.
Okay.
But that will be picked up on the next index that there's been a change in that directory, and it'll get re-indexed.
Okay. Move it into a different user's directory.
Yeah. Well, no, but